Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable session. This particular faculty roundtable session is with the Thomas Lord Department of Computer Science, and we have three great faculty here to talk to you about the computer science curriculum, the classes, the department, the student life and experiences that come as a computer science student here at the Viterbi School of Engineering. My name is Paul Ledesma. I'm the Executive Director of Undergraduate Admission here at the Viterbi School, but you won't hear a lot from me today. I'm just here to moderate the discussion because we have three fantastic people here to chat with you about the discipline. I'm going to allow them to introduce themselves to you each one by one. First we'll start with Dr. Raghavan.
Yeah, thanks. And, welcome to everybody. Glad you made it today. I'm an associate professor of computer science in the department, joined about 5 years ago after a number of years back and forth between a few different companies and research labs. I was at Google, headed up a couple of startups in different roles, was a research scientist in Berkeley, and then came here as a faculty member. And I have a pretty broad set of interests ranging from problems of networking, security, privacy, to problems in sustainability, both broadly and within computing.
Thank you very much. Professor Raghavachary.
Hi, so I'm Saty Raghavachary. I'm an associate professor in CS practice. And the word practice comes because I spent 16 years at DreamWorks Animation. I was there from 96 to 2012. And I worked on the first 20 animated movies, things that you probably watched when you were little, Shrek, Kung Fu Panda, How to Train Your Dragon, like all of that. I've taught at USC full-time since 2014, but part-time since 2004. And the transition has been pretty wonderful from industry to academia. And so my interests, I primarily teach, but I have research interests also, mostly computer graphics, and these days also some of AI machine learning. And the worlds are colliding, so I talk about that in my classes as well.
Is it bad that when you said those movies, I watched those as an adult and I continue to watch them as an adult, not as a kid? Satya, but I appreciate the movies very much, so I'm glad you're here.
Thank you.
Professor Ryutov.
Oh, hello, my name is Tatyana Ryutov. I'm an associate professor of computer science practice. I've been at USC a long time, and I'm a USC alumnus. I studied at USC as a graduate student. I teach data science and computer science classes, and most of my classes are related to cybersecurity, which has been my research field. And I teach one undergraduate senior level class, CSCI 350, Introduction to Operating System, which I enjoy teaching very much.
Fantastic. Thank you so much for joining us. So for all of our guests here today, this is how today's session is going to work. I'm going to moderate this discussion, make it like a talk show. I have a number of different questions to our faculty that are going to help you understand the classes, the curriculum, the major, the research, everything you can understand about computer science. And your job is just to sit there and listen. In the second half of the session, that's where we're going to turn it over to you, and you're going to have the opportunity to use the Q&A feature. It's disabled for now, but I'll turn it on in a little bit. And that's when you're going to be able to type in your questions, and you can ask as many questions as you like because it's going into that chat, into that Q&A feature. And then you all, as an overall aggregate audience, you can upvote the questions. And so it's a democratic process. We're going to go through and answer the questions that are at the top first and make their way down, but not yet. I'll let you know when we turn that on. So for now, just be thinking about the questions that you want to ask. And trust me, some of the questions you want to ask, I am going to ask first. So we've been doing a few of these. We know what the main questions are. So sit back, relax, let this conversation inform the next level of questions that we'll have in the second half of the session. And we'll get off and running now. The first question, seemingly probably the most simple question, but has a complex and complicated answer. What the heck is computer science? And I say that with the full context of, we have an audience of high school students. Maybe I've taken a programming class. Maybe I did Scratch. Maybe I've been programming since I was 3. But what is a degree in computer science? What's the discipline about? And there's a lot of things complicated about that. There's software, there's hardware. What is computer science? Whoever wants to jump in and dive at this one, I'm sure you guys can talk over each other too. Barath, did you want to start that off?
Sure, yeah. So, I like to think there's one basic idea in computer science, which is abstraction. And applying that one basic idea takes a lifetime to actually figure out how to do in all the different forms, in all of the different ways that we use computing. And by abstraction, I mean taking something that is extremely complicated and then breaking it up into lots of little pieces and making those pieces all work together. That's how we build software, right? We create abstraction and modularity. We build lots of pieces, we plug them together, and we can make extremely complicated things work. And there's a whole bunch of theory, sort of mathematical bases for all of this stuff, and then a lot of practical stuff that's built on top of it, and then everything in between. And really, computer science is the study of how to make all of these sort of information-based abstractions work to do all kinds of useful things. One of the other things that I think has changed in the last 20 years that isn't really talked about much is that computing and computer science used to be, you could think of it as an inward-facing discipline, where it was about how computing affects other computing. And so it was like 80-20, it was about computing's affecting other computing, computers are talking to computers, and it's flipped in the last 20 years. And not as many people talk about that fact, that it's actually 80-20 affecting society. It's everything that we build, everything that we do affects everything in society. There's nothing that's not sort of mediated by computing today. And so really what it's about is figuring out how do those abstractions map to society? How do we build software that works for the world?
That's great. Other thoughts, input?
Yeah, I want to build on what Barath said. So the idea of abstraction, actually, it extends to this notion that we call computation. So there's almost like a self-serving circular answer. You know, what is computer science about? It's about computation. But then the idea of computation is very cool, actually. So if I ask you what is square root of 5, right? You would not know that off the top of your head, but you can make a computer step by step get the answer for you. So when you go in a calculator, punch 5 and square root, that's actually what happens. So computer science is, in a way, thinking about how you would make the computer, this, you know, inanimate mechanical thing, go through step by step a process, which we call an algorithm, and then spit out some kind of result that you want. The result could be like a piece of Venmo money you're sending to somebody. It could be a video game you're playing. It could be basically anything at all. But then we think of all of those things that we do in the real world in terms of this idea that we call computation. So like Barath said, it's easy to talk about, easy to state, but then it does take like a lifetime to master what it is. And one more quick add-on, computer science is not equivalent to programming. So if you learn Java, if you learn C++, you learn Python, that is not computer science. I mean, obviously computer science includes that, but those are vehicles. Those are basically mechanisms, you know, those are things we use to make these algorithms, all of them come true. So in a way, it's like a way to express computation is actually what it is. So computer science is way beyond just simply like learning C++. In computer graphics, I would hold this mouse and say to you, if this was described in terms of some kind of a, you know, computable object, then what the computation would do is turn this into pixels. In other words, I can basically render like in a Pixar movie, DreamWorks movie, you would see a character is holding something, but there's no video. So how are the pixels being generated? That is computation. So practically everything that a computer does, every app that you ever run is all computation. And so CS is a discipline that studies like all of that.
This is great.
I would like to add to what my esteemed colleague mentioned also something. You know, when I was a student at USC, one of my friends who studied physics was joking that any discipline that had the word science attached to it, to its name, like computer science, was not really science, since real sciences like physics, chemistry, or math didn't need to call itself science. So now my friend is a software engineer and doesn't joke like that any longer, and is a big fan of computer science. So on a serious note, computer science, as you know, my colleague mentioned, is a very broad discipline, combines principles for engineering, math, computational theory, constantly advancing field with new trends emerging every day. So for example, my field of cybersecurity changes constantly. And it evolves, it tries to come up with new ways to stop breaches, address vulnerabilities. And we also observe similar trends with, you know, Internet of Things, virtual reality, AI, robotics, and so on. So there's also kind of nice balance to the field. It's kind of both theoretical and applied, including algorithm theory of computation, information theory, as well as hardware and software design and implementation. And you guys, if you study computer science, you will have firm understanding of underlying principles of programming, algorithms, you know, be able to design software and systems. And, you know, there are also special areas, like if you're interested in the graphics, computer security, databases. And, you know, practically getting a degree in computer science will give you long-term job security, above average starting salary, and diverse job perspectives in a range of industry and academia.
Great, thank you. Let's jump into, because this is things you started to allude to in all of your answers, which is the curriculum and the classes. And can you help our guests understand what is the undergraduate curriculum and how does it start? Where does it go? It's got lots of options, specializations, there's different course plans. And I think, Saty, to your point, you know, you kind of, I'll let you kick this one off because you started talking about this in your answer. where computer science is not programming, but maybe a lot of our students have programming experience. And so oftentimes they think, hey, I've got this. I know what I'm doing. So how do we get started, and what's our approach to this, and how do we get them through it?
That's a good question. So it's like a pyramid where we start at the base, and then by the time you graduate with an undergraduate or even a master's degree, you're at the top of the pyramid. So we basically build you up to actually go in the world, and then use this, this abstraction, this computation idea, and actually change the world, like, write ChatGPT, for example. So in the base, at the very bottom, we actually do start with programming because, even though programming is not equivalent to computer science, practically all of computer science disciplines need programming. So you need programming knowledge. So our first few courses do have to do with things like C and C++. Those are the languages we use. But then from there, we move on to things like data structures, which are how you organize like what you want to compute. And then this cool idea called the algorithm, where everything comes together. So those are some of the first year courses. And then there are some more foundational courses on things like networking, operating systems, and even a little bit of computer graphics. So that is so we build up more and more knowledge about what computer science actually is. And then you have electives. You can talk about software engineering. You can take like a more graphics class if you want, or a cybersecurity class. So all of these various aspects of CS is what actually goes to make the undergrad curriculum. So that is what I would call the core CS curriculum. But if you are more interested in games, for example, we have a CS, games like specialization, where more of your electives are going to be more about game programming, level design, computer gaming, architecture, and so on. Likewise, we also have a CS BA, like business administration concentration, where your electives might have to do with things like business analytics and so on. So that is how you branch off and take this overall broad base of computation and apply it to one specific field. And we also have an electronics engineering specialization, where if you're more into computer chip hardware design, then that actually merges the notion of chip design and also software. So you could actually specialize in that if you want. So we've got a few different tracks you can go, but all start with the same base.
That's great. Just as a follow-up to that, we have a number of our students tend to think, when we hear kind of these buzzwords, data science, artificial intelligence, computer graphics, what you're all referring to as like end use applications, or, the idea of where they're going with it. Sometimes a lot of our students feel like they're supposed to have it figured out, that they're supposed to have it all kind of like they know exactly where they're going when they start. Can we talk about that evolution of a student as they go through the curriculum, where they go? And then maybe if you all want to jump in with classes that you teach along that pathway that help them figure those things out.
I'll say something quickly and then get out of the way, and Tanya and Brad can talk more.
Please.
Yeah, definitely that is true, that you don't need to know ahead of time like what you want to do. Although it is cool if you do, though, because maybe you program some video games, in high school, and then you love to, take that like further. So that is definitely a good thing. But it's not that every single student who comes into undergraduate curriculum freshman year needs to have it all figured out. Not at all. Because some classes that you think are fascinating actually might not turn out to be that at all. So it's good to keep an open mind, and then basically just let the, let the courses guide you, let your interests guide you, and see where you end up.
Barath?
Yeah. So, I also find that specializations are sometimes nice, but the core ideas in computer science are shared among all of these different sort of specializations and sub areas of computer science. And that's why you learn these core topics in the first couple of years. It's because they are the foundation, like Saty was talking about, that you need before you can do those other things. And then those same ideas will keep recurring as you go through the upper level classes, but you're applying them in specific contexts, and you're using specialized tools. You're learning specialized techniques that are specific to, say, AI or to security or to operating systems. But once you get familiar with a lot of those, you'll start to see the patterns that connect between a lot of these different sub areas of computing.
Great point.
I just want to briefly add, some students come with different backgrounds, especially different programming skills. And I just want to add that we do have different levels of classes based on your programming, background, and you can actually allow to skip some. So, for example, we have the CSCI 102 Fundamentals of Computation. It's a kind of preparatory requirement. So, if you have programming experience, then what you're allowed to do is just take a placement exam to waive this requirement. In the end, kind of everybody reaches the same high level, very good level of programming skills. But as Saty said, CS is not just programming, it's much, much more.
Yeah, thank you for bringing that up. That's an important point. We often have a lot of students that are hardcore and some students that have never done it before, and realize that we graduate these students with equal success and they have different starting points, but we'll get you caught up. And then to kind of echo a point, put it in slightly different words to our students, especially that are focused in CS, they tend to come in with this idea of what it is they want to do, or thinking that they're supposed to have it figured out, or maybe they read this really cool Wired article on, you know, something that's so hot and cool and fun that they want to do. And the best advice I can give is trust the plan. Like, get into the program, let the courses envelop you, immerse yourself in the curriculum and the experiences. And as Saty said, something that may sound cool, maybe you don't like as you start actually doing it. And so go after the things that you start to like as you experience that. Let's talk a little bit about the other side of academia, right? We've got classes and teaching, but we are also a research institution. Can you talk either globally about the research that's going on in the department, or research that any of you might be specifically conducting right now?
Yeah, I'm happy to. So, I have a pretty wide range of interests and research projects that are going on, both with collaborators here at USC and, all over the country and world, really. One of my core areas historically has been networking, both in research, and I was in the team at Google building some of the networks at Google and designing the systems that manage the networks. So networks is really about, how do we make the internet work? How do we make all the different new protocols that need to run over the internet? How do they interoperate? How do they not step on each other's toes? There's a lot of different problems in that space that my research group has worked on over the years. Then how do we make it secure? How do we make it private? And this is everything from, how do you make sure that your mobile phone isn't tracked and your data isn't sold when you just walk around, to how do we make all the different systems that are collecting our information a little bit more safe, so that they aren't getting breached all the time. So there's a whole range of security and privacy problems. And then a bunch of work on sustainability, both of how do we make, say, data centers more energy efficient to use renewable energy, to things like, how do we make agriculture more sustainable using AI and other techniques. So, pretty wide range of research that I'm doing in my group.
So I did research at the DreamWorks, because you can actually do research in the industry. Like when an animated movie happens, maybe the artist wants a very special kind of an effect, like a fire-breathing dragon, for example. So the software that they use, in this case, the Maya, would not have a button that says dragon fire. So we'd actually have to go back to the basics, so to speak, and actually figure out some new technique of making that fire that's never been done in the world before. So in that sense, it is a lot like the research that happens at universities. So that's the kind of research that I did at DreamWorks before I could write the tool that the artist wanted. But here right now at USC, I do teach full time. So for me, research is optional. So I do what is called a directed research. So a student could come up to me and pick a one-on-one topic. They might like to write like a new recommendation system that is better than Amazon's recommendation system. So we pick a very small, narrow, doable topic in 1 or 2 terms, and they would sign up for like a 1-credit course. And then we have a lot of fun, both the student and I, but we actually explore something real. So in that sense, I do a tiny bit of research, but it's not really, required for me.
I just want to briefly add just something, that we have this multidisciplinary research, which is, I think it's very cool. So we have a number of top schools like Keck School of Medicine, Cinematic Arts, Annenberg School of Communication, others. And there exists a kind of a close collaboration among the schools. So for example, we had this research together with Keck School of Medicine. And as a result of that, I developed with my colleagues interdisciplinary new class biomedical data privacy, which is kind of very cool.
That's fantastic.
And we have this new generative, sorry, Paul, I want to say, we have this new generative AI center that was announced like a few months ago. So that's also interdisciplinary, like Tanya was mentioning. So those kinds of things give you opportunity to work with multiple schools at the same time and then do some kind of a collaborative research. That is quite neat that USC has that. Not many schools have that. They're very compartmentalized, okay? But we, are more like across borders, yeah.
Absolutely. Thank you. And undergrads can get involved in all of this research as well. And we also have additional funding opportunities through our Center for Undergraduate Research in Viterbi Engineering, what we call CURV. And so any undergrad can get involved and apply through that program and get involved, in addition to just talking to faculty such as this, if you have interest in that, something that our students do quite regularly. Let's talk about the end of this process, right? You know, when students come through the computer science program, and Tatyana, I'm going to have you start this one off. Where do they end up going? You know, students that you know, where have they gone? What kind of companies have they worked at? What kind of jobs do they have? And they also some will go off to grad school as well. Just, you know, anecdotally, things that are out there.
So we're in terms of work, or what kind of employment they get. Well, they go to the best places, you know, the dream companies, of course. You know, we're a top school, and they really want our graduates. So that's just amazing perspective for our students, definitely.
Any other ideas of maybe some specific companies that people know of that you know with your students that have gone to? Barath?
Yeah, so you know, a huge range. It's usual suspects and lots that you haven't heard of. So you know, students of mine have regularly gone to Amazon and Google and Meta, Netflix. I think some of them maybe have gone to OpenAI recently in the last year or so. A huge range of game companies as well, very, you know, big pipeline to game companies and graphics studios. And then a recent trend, last probably 3 years, and this is something that I've been encouraging, is students that are starting their own startups. You know, I've been involved in the incubator on campus that provides a foothold for students to get started on their own startups. There are classes at the senior level where you can sort of focus on ideas that you've got that you want to go and turn into a startup. So there's a pipeline for that, and a lot of students are going that way too.
So I'm going to say the same thing. My students, again, basically go to every top company you can name. So including like what Barath named, even like Visa, you know, to add all of that, LinkedIn, eBay, Tesla. Literally, you name like some top company that, you know, our students actually work there. So we're super proud, because you would think that Berkeley, you know, and Stanford, basically, you know, like all the students take all those jobs that Silicon Valley has to offer. But bulk of them actually, you know, that are in those jobs are from USC. It's very gratifying for us to see our students fly away and do cool things in the world.
Yeah, I'll also add in, this was kind of alluded to in these answers, but you know, having a quote computer science degree doesn't necessarily mean you work at a quote computer company. Software engineers, as described in all of our other answers to this question, go on to do a number of different things and are multifaceted problem solvers. Even at just the bare minimum of SpaceX needs software. SpaceX hires computer science students, and this type of idea of where you work is not defined by a degree. I want to make sure that everybody understands that. And that is across industries worldwide. So there are lots of opportunities out there. And this also includes internships. You know, a lot of students ask questions about internships, and everything we just talked about is kind of the end process of a participatory experience of students interning at these companies prior to getting the jobs that they get. So working with our Career Connections office and having those internships, and a lot of these larger companies that have been mentioned are really even focusing more on hiring younger interns as first-year students, because they're trying to create multiple year internship programs. They kind of get their hooks into you young. Meta does this, Google does this. They want to get you in so they can kind of keep you coming back. They find the good ones. They want to keep you coming back and get you into that corporate culture if you want to do that. So these opportunities are here for you as well, if that's something you want to do. Now, I'm going to open up the Q&A for all of you out there. So now the Q&A is open. You can start typing in your questions. I'm going to leave you some time to do that, because I have one more question I'm going to ask our faculty, and then we'll turn to your questions. So please put your questions into the Q&A, ask as many as you like, and then it's up to you as an audience to upvote them and continuously go down and pull things up that you want to see answered to the top. Once those questions come to the top, I'm going to start answering them in that order that they are upvoted up. So it's really up to you all as a democratic process. So as you're doing that, my last question to our faculty is about the unknown. It's about the future, right? So what are you excited about with the future of this discipline? Where is this going? What do you think is going to be happening in the next decade or so?
I can give you like a quick little perspective. Shall I go right? Yeah. So I see like two different amazing things, you know, from like where I stand in terms of what I know. Computer graphics is one of them. So NVIDIA, to be very specific, you know, they have this thing called Omniverse, where they basically want to recreate the world in all its glory, photoreal glory, a virtual world where we can all like basically travel, schmooze, you know, talk to each other. See, if the pandemic ever comes back, then we'll not have little Zoom squares of students. We'll actually have 3D. It'll be better than the Zoom call, where you look to your side in 3D and you'll actually see a colleague sitting next to you. So I see a pretty tremendous, amazing, you know, opportunity and like excitement there as well. that's one thing. Second is generative AI. So AI is now slowly starting to create things like music and video, images, obviously, Midjourney, Stable Diffusion, all of them. So I see a pretty exciting time where, so many of us can become amazing content creators, tell stories, like all of that. And so computing is exactly what's going to get us there.
Yeah, one of the things that I'm starting to see is that we're at this inflection point where a lot of computing has been used for sort of, you could say, the low-hanging fruit in society, right? We've been, for the last 10, 15 years, we've been optimizing the little things that, businesses have needed and society has needed. And now we're at this point where computing tools are actually much more powerful, that we can do things that we couldn't really do without a lot of sort of manual effort. And so this kind of automation, while there's, a lot of discussion about sort of the risks of automation, about, well, if somebody was doing that job before, now if a computer's doing it, what are we going to do? But really, one of the things that we're seeing that's interesting is that it's actually freeing up the sort of creative process. One of the things that you're starting to see is that it's actually opening the doors to people to be able to ideate, to create new things much more quickly. And so that's a tool that's almost becoming democratic. It's not that only some people are going to have access to the sort of creative side of computing, but actually it's something that everybody is going to soon have access to. And so it's actually going to enhance creativity overall, and really let people go from A to Z of what they have in mind in all sorts of areas.
Tatyana?
Yeah, I agree with my colleagues. I can add that the field has seen impressive progress over the last decades, and it doesn't show any sign of slowing down. In the scope of computer science professionals is consistently increasing because technology advances, right? So if you think about our daily activities, they are powered by computer science. And for example, again, my field of cybersecurity, which is a field of computer science, involves protecting network systems, programs, and digital hacks. Well, what used to be just, cybersecurity now is just security, because cyber attacks are no longer about data. They can now affect our life, property, cars, medical devices, power plants, and so on, right? So we all depend on this. So other technology kind of demonstrates similar trends, blending with computer science, even, this quantum computing, it's still the same. It's follow the same computability rules as classical computing. So no quantum computers, as understood currently by mainstream scientists, can solve the halting problem. So you really need to understand the theory of computation. Computer science is going to be here.
Great. Thank you all very much. So as a reminder to our audience, the rest of this time is completely up to you. So keep asking questions and don't forget to keep upvoting. Usually there's a big surge of upvoting in the beginning, like I've already seen, but do not forget, because we're going to go through these questions and we might start running into a lot of ties. So I want to make sure that you are continuously upvoting these questions as we go into it. The first question comes from Sanvi. Sanvi is asking, can you expand more on the AI Center? And I think, Saty, this is in relationship to you talking about the Generative AI Research Center. But I'd also like to expand this question a little bit more, because oftentimes students hear about announcements of new research centers and they think it's related to the undergraduate curriculum, and there might be some trickle-down effects. But can you also talk about how AI is incorporated into the curriculum, and then maybe talk about what that research center does?
Okay. So I know just limited perspectives I'll share, and Barath could probably chime in and say a lot more. The center, the Generative AI Center that the President Carol Folt announced, is going to involve multiple departments. For example, the Annenberg School of Communication, Department of Education, and most certainly Viterbi. So the idea is to get into, mostly research really in society-changing applications of what this generative AI thing can do. For example, I mentioned video generation, right? So it might come to a point where AI can come up with a nice script for a story whose plot line that you give it. And then it might even go on to make the whole Pixar DreamWorks style animation, like all 90 minutes of it, including audio, including music. I mean, the entire thing. So imagine what an amazing world that would be. So we want to be at the forefront of all of that. So that is actually what the center is about. So which means it might involve lots of research opportunities at the PhD level, but there might be courses also that the people that are part of the center might come up with, and those courses might be available to undergraduates. So it's not predominantly something for undergrads, I'm going to say, but then there definitely would be some place where you can participate.
Yeah, AI is often it's something that you'll discover, you'll be working on and developing, but AI is one of those elements similar to robotics, similar to these elements of machine learning, where it's kind of the advanced discipline, right? So the idea of an undergraduate degree in computer science can start to touch on it. And then as you move forward in graduate education, that's where the real work starts to happen in that area. And so a lot of students, I think right now, love the ideas of these concepts of robotics and machine learning and artificial intelligence and quantum computing. These are data science, all graduate level programs. Things will get touched on, and computer science is the perfect entryway and the perfect background to go into these elements and to have that background. But it's almost like it's the application of computer science, if that makes any sense. I don't know if that registers with all of you, if that tracks well, but that's how I would refer to it as.
Yeah, and one opportunity for undergrads to really take some ideas from AI and what they learn in, say, their junior and senior years and apply it is there are a number of student organizations that are doing really their own research with faculty mentorship. So for example, there's an organization called Case++, which is Center for AI in Society, which is really about how do we solve these hard societal problems that are all around us and use AI techniques to that end. And so the Case++ student group has their own training program where they teach some of the extra skills that are needed in AI, things that are complementary to, say, master's level or higher level coursework, and then apply that to problems that they define themselves. And so the undergrads then present that work, they mentor more junior students, and this is a huge opportunity for undergrads.
Thank you. Next question for Solomon is, what is the main language used in the curriculum? Saty?
Basically, it's C++ is the main language. And so if you're not really comfortable with C++, we do have, like Tanya mentioned, a C course. A C came before C++. So it's a little bit of a lighter, milder language, so to speak. But C++ is the main language, but not the only language. We also use Java in some of our courses as well. So
yeah, and I think that this is often a misread thought from high school students, which is like, what language do I need to know? And they start asking the schools. And I think our approach really is we have that core in C++, because then that knowledge is applicable in any language that they use moving forward. If they're going to be doing stuff in R down the road, if they're going to be doing stuff in Python, if they're going to be doing stuff in SQL, like any of these elements, are knowing the C++ in the beginning is how you're going to build into that. And I often make the joke that, like, any job you're going to get, it doesn't matter what you've been trained in, is whether you're going to be able to know what they're doing in their particular office and their particular background. So maybe spending a night with a book to understand it, but you have the basic syntax and structure of how to program, starting with C++, because that's where it all goes in.
So true. If you learn C++, Python and other things are like much easier to pick up. Plus, I also want to add one more point, because we all three of us said CS is not the same as programming, and that's only because imagine when you have a thought in your head, okay, any thought that we have in our head, it's not necessarily in a language, a thought is a thought, right? And then we express the thought using maybe more than one language that you might speak. So that is exactly how programming languages are. So when we actually think about like a research problem, like a new kind of recommendation engine for TikTok, for example, we don't start and go to the whiteboard and say, how do you do this in Python? The language comes last, okay? So computing is all about leaving the language alone, the programming language, and actually coming up with how those blocks are going to make a recommendation system. So if you approach programming like that, then you wouldn't be worried about what the main language in the curriculum is. Basically, any language can start you off, and from there you can pick up any other language, because language is the last thing that you should actually worry about.
That's a great point. Thank you so much. Alicia is asking, are there any student organizations or clubs for hands-on experience in CS? And I'm going to prepend this question with one additional question I'd like you to answer. A lot of universities that students are looking at are more theory-based education and don't have hands-on work, but we do have hands-on work inside of our curriculum. So can we talk about some of the hands-on work that students will be doing just by taking the classes, and then maybe we can supplement that by some of the student organizations that we know does additional work as well?
Yeah, we have a capstone course, actually, if nothing else. So the capstone course, just by definition, is supposed to bring together practically everything that you studied up till that point. So people usually do this in the senior year. So those are pretty non-trivial, term-long projects. Sometimes you even have industry sponsors. You'll actually talk to someone outside the department and get ideas from, them, like guidelines and maybe, requirements. And then as a team, code all that and come up with something very cool, a big project to be proud of. So in that sense, our courses do have hands-on experience like that. Plus also many programs like homework projects, are not just simply Q&A multiple choice, right? It's not that at all. they all do involve programming. Like I teach graphics classes. So practically every one of my courses all involve writing a little piece of program that is going to do something with computer graphics. There's no option that says I'll read some kind of paper and summarize it, for you in English. It's all programming. So we do have programming built into basically every single course. But yeah, we do have student organizations as well. There's one specifically for data science as an example. And then there's a few others that I can think of. There's one called Corpus Callosum, where art and science students meet, and they use things like Arduino microcontrollers that they would put on a skateboard and make it do a pretty cool animated LED patterns when the person's skating. So you have like all these creative and nice technical opportunities to express yourself outside of the classroom as well through student clubs.
One of my favorites is Code the Change that does a lot of work with nonprofit organizations in the LA area, and they build out websites or software applications completely as a nonprofit themselves, as donating their time. Sorry, Barath, I stepped on you. You're about
no, yeah, exactly. Code the Change, Shift SC, Case++. There's so many of these kinds of student organizations. And one of the things that I really like about all these student organizations in CS, and they sometimes are interdisciplinary, is that they're student run and student led. So that's not somebody telling you what to do, but rather you get to express your creativity. You use the skills that you've learned in your coursework, but to practical problems that you see all around you. And like I was saying, that shift that's happened in computing, where it was 80-20 inward facing, that's done. Now it's all about what's going on in the rest of society and how does computing play a role in that. And students are rolling up their sleeves.
That's great.
Good point.
Thank
Our
you.
dean actually calls it CS plus X, right? So our dean, Yanis Yortsos, he calls it CS plus X, where CS is CS, and X can be anything else. It can be biology, civil engineering, accounting, education. So it's all about applying, like Barath said, the principles, that we've developed over all these decades. So finally, the time has come for the society to benefit from all of this. So that's what X is about. So you can apply it to anything you want.
Yeah, rather point. Go. Sorry, please.
So we do have some classes are just pure theory, but most of the classes have very nice balance of theory and hands-on. So for example, my course provides introduction to operating system design and implementation. It's kind of very tough course, and students learn foundation concept, the principle of operating system, many of which we generalize to other areas of computer science. So it's kind of an engineering, it's useful. But there's also difficult hands-on projects in C. So students have to modify and debug existing Unix operating system called XV6. So they kind of have to develop themselves new OS functionality related to thread management, process synchronization, memory management. It's very different from when you're developing an application, when you're actually extending the real operating system. So projects are really hard, but according to the students' feedback that I get, they're very rewarding. So they learn how to overcome this challenge, kind of dive into system. They feel that they have control, and it's just very nice to see that they get satisfaction from messing up with this XV6 system. So it's cool.
Very cool. Thank you. Our next question comes from Petros, which I will address, and then if anyone else wants to jump in on this. But Petros is asking, does USC give an advantage in terms of getting internships before you get your degree so you have a job lined up? And I think what you're asking is, does USC give you a better chance of getting jobs? No. And I want to be really, really clear about this. No college that you go to makes it so that you have a better chance of jobs. People talk about like, oh, we go to that college, you get better jobs, whatever. You're all looking at great engineering institutions, and students come out of each of those very successful. And when you go get a job at a company, whether you're the companies we talked about, whether that's the usual suspects, Amazon, Google, Meta, Apple, like all these different companies, you're going to be working alongside people from other universities that graduated and have the same level of background to you. But we are working incredibly hard to make sure that we're lining up as many opportunities to come to campus. So all the companies we talked about are recruiting on our campus. They're coming to campus multiple times, hundreds and hundreds of employers working with our own Career Connections office. And something we do different than a lot of other universities is we have our own Career Connections office in the Viterbi School of Engineering. So we have staff devoted to working with those relationships and also working with US students to go in that process. I never want to say something's lined up for you, because that implies they're kind of handed out, and internships are never handed out. It's an opportunity for you to engage. And so if you are engaging in the experiences, if you're going to the networking events, if you're going to the career fairs, if you're going to resume critiques and mock interviews that we've all putting on for you, you will be very successful. But if you don't, you're going to have some challenges. And more specifically, I will also say that students are most successful at the institution that matches them the most, where they got the most out of their faculty relationships, they got the most out of the students that they were with, and that made them the best version of themselves, therefore much more desirable for hiring managers that are out there. I don't know if there's anything else you all want to add on to that.
Yeah,
I'd like to
completely agree.
I'd like to
Tatyana.
add very quickly, you know, USC is kind of special a little bit because we have very, very supportive alumni network.
Mhm.
And it's very rare in this respect because alumni genuinely help each other. So Trojans, employers often seek Trojan employees and will notice USC on your resume.
Great. I'm going to move on. One thing I forgot to mention, and I apologize for this, we're not taking any admission questions or application related questions on this. This is purely for our faculty in computer science. So I'm going to start dismissing any admission questions. We had an AMA earlier this week. You can watch that recording. We have lots of information to admission. We have other admission events that Angie can put a link into the chat for you to register for, where we talk nothing but admission and nothing but application process. But today's going to be all about this discipline. Next up is Eric, and I'm happy to provide some context to this, but then also whoever you want to jump in with your perspectives. But USC has announced plans to create a school of computer science. How is that related to Viterbi? It is Viterbi, man. That's us. And this is, I think, more infrastructure related for the university. There's a lot of new funding that's coming in, and it also, nothing's changing in the Viterbi school other than more resources, more money, more faculty, and a lot of this is about university support as well. The opportunity, I think, a lot of things we've talked about here, or maybe we've alluded to, is the computer science or programming or computer knowledge as that next literacy. And so other majors on campus to have the support of this type of school with more funding to support those other majors that are out there, that's going to be a big part of it as well. But it's just going to be more stuff, if that makes sense. But other perspectives from all of you?
Well, we also get in and bring new state-of-the-art building next year, which is very
That's
exciting.
true. Slightly different funding sources, but yes, but that's the best part about it. Yeah, we're getting a whole new building, which is unrelated, which is funny because I remember when we built Ronald Tudor Hall, and at the same time we were named the Viterbi School, and they thought, oh, Viterbi School, and you're getting the building, like two completely different things. And that's exactly what's going on with Ginsburg Hall, which is right here behind me. I broadcast from the future, by the way, when the building's entirely complete, opening in spring 2024. So just a couple months away from that raw opening. But yes, that's a brand new building that will be opened up this year. Daniel asks, how easy it is to switch between CS majors? Very easy. You just let your advisor know. And so when you start in one, you're not locked into that. Next up, we just answered that same question. Sahar, so good. How does USC intersect with robotics at USC? Well, again, it's embedded into it. You can't do robotics without CS. And I will say that we have one of the largest centers for robotics and embedded systems research in the country. Anyone else want to talk about robotics?
It's actually super cool. We've got quite a few different disciplines within robotics going on. For example, we've got Professor Maya Matarik. She does socially assistive robotics. So this is when a robot could literally interact with somebody that might have autism spectrum disorder, for example, and bring them out of their shell. You know, that's actually very cool. We also have robotics actually faculty working with even Amazon, it turns out. And then, lend some of our expertise, to that as well. So yeah, there's all these different areas and this humanoid robot research going on. I mean, there's a lot of different variety of robotics. And also one professor actually interacts with robotics, and she combines robotics and graphics, haptics, for example, feedback gloves, how does that work? So we do have, quite a different kinds of robotics going on.
In addition to that, we have, the field of robotics has expanded so much that really robotics is now part of the world. So we have research groups that are doing, self-driving vehicles, and not just individual self-driving vehicles, but how do whole fleets, multiple vehicles coordinate with each other while they're self-driving? How do they do that in complex scenarios? We also have faculty who are doing robotics who are thinking about the language side of it. How do we interact with robots using language when the world around us is ambiguous and a robot may or may not understand what we're talking about?
Great, thank you. I just dismissed two questions that were transfer related. Angie's going to put a link in there so you can learn how to talk to transfer counselors. But you guys have nothing to worry about what your questions were. But we should go to one of our transfer admission events to learn more about that process. Nadia is asking about students double majoring in computer science and other fields like engineering or humanities, how successful they are in completing both majors. Let me give you a little bit of background on this. You can do whatever you want. That's number one. Number two, you might start changing your mind when you see how much work is involved. So it's a question of a full degree in computer science on its own is a full 4-year program. Students often minor outside of their program and still do that within 4 years. We have students that double major, and of course that's possible, but I want you to realize that's likely going to take you more time, although some students do it less, but I just want to manage expectations appropriately. And I will say, you don't ever do anything with engineering. You already got that. Like, go find something else to add on to it. As Saty was mentioning, CS plus X. What's the other thing? What are you impacting? What are you growing in? Where's that possibility of that? So think about that. But do you guys have any thoughts on this idea of interdisciplinary studies inside of a computer science degree program?
Yeah, I have actually many students, who come to my undergrad classes who have all kinds of minors, or they have a major and CS is the minor. In other words, CS is combined with basically almost anything that I can imagine. School of Cinematic Arts comes to mind, or maybe music, even dance. Like all kinds of economics, for instance. So many disciplines out there that all, the students there want some aspect of CS combined with their core as well. So yeah, we just see it all across the spectrum.
Very cool. Manu is asking about with CS and BA, what do postgraduate jobs look like? Same ones we just talked about, although a lot of them, they will sometimes go into like the business side of consulting in that area because maybe they want to bridge that gap a little bit more, maybe speak more of the business language. And the courses look like, we put a link to the curriculum in there. It's the same set of courses with a couple things shaved off, and that you also take business courses alongside your CS courses as well. So marketing, finance, accounting, organizational behavior, those types of things as kind of a basic core of an undergraduate business degree program. Some students in CSBA kind of tend to call them, at some point in their degree program, I've heard it described this way: Mondays and Wednesdays, I'm a business major, and Tuesdays and Thursdays, I'm a computer science major. They kind of flip-flop between their week. So that's kind of the best way to think about it. Next question. How easy is it to transfer into the Viterbi School? If that's an admission question, go to our transfer session. If you're thinking that you're going to be at USC in another major and you want to transfer in, not easy. We are completely full. Once we have our incoming class, we're done. And so do not try to get admitted to another program at USC and then try to work your way in later. You will have to do at least a year of coursework with a possibility of that never being accepted. So you don't want to go down that road. You want to start in CS. Make sure you're putting CS as your application, first choice major on the application. We only have about 6 to 7 minutes left. So get the upvotes going. We're running out of upvotes. I see you guys got kind of no more upvotes going. So we're getting down here. If you want to push something up, make sure you push it up. Solomon is asking, does there exist or will there exist future classes for quantum computing as it's starting to begin its growth as a subject in terms of a CIS? I'm assuming he's talking about another university because CIS is not a program that we have, but computer science is a program we have. And so quantum computing, this is a little bit related to what we talked about before in the undergraduate program. I mean, this is something we deal with. We have one of those quantum computers, the D-Wave, I believe it is, at ISI at USC. Can we talk about quantum computing and how that relates to the curriculum?
Well, D-Wave actually is not a real quantum computer.
Oh, excuse me.
So let's not confuse it. But we don't have any minor or any special program on the graduate level, but we do have researchers at Information Sciences Institute who do research on that. And that's probably for graduate level studies. And on the graduate levels, you have this possibility to do directed research in something that you're interested in, quantum computing if possible, but it requires much more preparation.
Sure. It's a very specialized field, so just to make it very clear. So it's not as broad as CS, and probably would never be, because quantum computers cannot replace like our CPUs that we have in the world today. They're meant for very specific tasks, which they're pretty good at. And so in that sense, there'll not be a brand new entire curriculum for 4 years that is entirely centered just on quantum computing. So it is, if anything, an add-on at the master's or the PhD level, just to like set expectations straight. But we do have the device, like Tanya mentioned, we have a place called ISI that is not part of the physical USC campus. It's in the marina about 20 miles away, but still fully tied with USC, obviously. And many people that are in the CS department actually do research there. So students might have opportunities to actually go work on that quantum computing D-Wave machine, but then it's not really widely available resource, I'm sure.
Lucas is asking, what would you say the focus of USC's computer science curriculum, applied or theoretical? It's about a 50-50 split in all of our degree programs. Some classes are going to be all theoretical. Some are going to have a mix of applied and theory. Some, like you get to capstone classes, it's just all applied. You're building something. I mean, the large scale software system class where you're building out these apps and programs for outside clients is a completely application-based class. So it really depends. But any other thoughts on this? Application versus theory?
Like you said, it's a huge mix. We have both, and a lot of courses, really the two are combined. You need to have some amount of theoretical understanding to be able to put those things into practice, and you need to have the practical applications to make the theory useful, right? So they're hand in hand.
This is a question that we get a lot of about data science versus computer science. Where do I can focus? I don't know what that means. Oftentimes students are confused because there's a data science program for Dornsife students, which is, for all intents and purposes, an opportunity to kind of ramp up a liberal arts degree program with some computer literacy, for lack of a better term, and that's there. But when students want to study data science at the undergraduate level, I always tell them computer science is where you want to go, because data science is that master's level work that comes out of that. Can we talk about computer science versus data science and how data science is kind of that embedded into that as you move on?
Absolutely. I actually teach the very first course in the undergrad data science curriculum sequence. It's called DS250. So I lay the broad foundations, hopefully, so to speak. Yeah, so that's a very cool thing that USC offers, this double major or a minor in data science. Almost no school in the country or the world actually does it, because data science is mostly considered a graduate, like an add-on to the curriculum. So we do that at the undergraduate level. And yeah, they are in some ways distinct in the sense that data science, like the word implies, it's basically all about, it centers on data, and of which we have too much in the world these days, and it needs to be analyzed. And so CS is more broad. Like, for example, graphics, computer graphics and networking, those would be called actual proper CS areas. And data science might not actually teach you anything about networking at all. So in that sense, you can actually choose, pick and choose what you want. So if you want something more broad, like Paul said, definitely pick CS. Because if you have the CS background, you can easily apply that to data science and pick all that up very easily. Whereas data science will definitely, jump you more narrowly down data science, for good or bad.
Yeah, and also the ideas of data analytics and data-driven decision making. These are elements that are built into actually almost every single engineering degree program. Exactly. And I think a lot of people are not necessarily overinflating this idea of like, I got to have a degree in data science. It's like, we need to have an understanding, and again, like a literacy, an opportunity to make those decisions. CS is the best place to do it if it's what you want to do. But also, we just had this session yesterday with civil and environmental engineers, and they have data analytics and decision making and probability schemes all built into the civil engineering degree program, because they need to have an understanding of analytics and data-driven decision making, as does every single engineering program. So a lot of people don't know that is just like kit and caboodle inside of degree programs already in engineering. The reason it exists for Dornsife students is because they don't have that. And so when you're a Dornsife student liberal arts program, that's an opportunity to ramp that up. Again, part of that opportunity to increase literacy in those areas.
It's interesting you said they don't have that, right? And they actually should, because science is also the exact same thing. All our experimental science, even sociology, which is soft science, not a physical science, does have data. As soon as you send out a questionnaire, people answer it. That is data. And so then suddenly you have this data analysis, situation. So you don't need to know about data, no matter what field you're in. Actually, it does come down to that.
I lost track of the time. I thought I was going to go another question, but I need to start wrapping it up. So I'm going to leave that to you all to have final words, one by one. Any final words or messages for our audience? Or if you see something in the chat, in the Q&A that you really want to answer, please have at it. But Tatyana, I want to start with you. Any final thoughts for our students here today?
Okay, sure. So I just want to, guys, don't skip theory. It may seem like it's dry, but it's very, very needed. Even from practical viewpoint, it's necessary to learn theory, a foundation of a discipline like computer science. So theory allows you to deeply understand problems, find new solution, teaches you to think rigorously and carefully, and it allows you not to waste time on so-called new frameworks, new buzzwords that actually correspond to things that have existed before, just new names for them. And for example, trying to solve something that was proven to be unsolvable, right? And when we have multiple similar problems, it's often beneficial not to solve each one by one, but have like a general algorithm which will enable us to solve all of them. So understanding which problems can be algorithmically solved is one of the main objectives of CS theory. Don't skip theory.
Thank you. Saty.
I'll co-opt Nike's logo. Computer science, just do it.
All right, Barath.
Yeah, I just want to say computing really is about how to think. it really shapes the way that you think about the world, the way that you use abstraction in the world. And it's really something that you can then, that way of thinking, you can apply to all kinds of things in life.
This is great. For all of our audience members, I truly appreciate you taking time to visit with us today and learn more about the computer science program. If you missed any of this, the recording will be on our YouTube channel, youtube.com/Viterbi Admission. And if you are applying, make sure you get your application in by the deadline. We're fast approaching that deadline. You can see our website for all the details related to applying that early action deadline that's coming up. And most importantly, thank you to our esteemed faculty for joining us today, Professor Raghavan, Professor Raghavachary, and Professor Ryutov. Thank you so much for being here. We truly appreciate it. It was a great conversation. I think you shed a lot of light on the discipline. Thank you so much, everybody.
Thank you.
Have a great evening.
Good to
Thank
be
you.
here.
Bye.